Okay, welcome to another Ginger Mathematician video where I'm going to go through all the IGCSE questions I can find on sequences. And this is valid for 0580 and 0607 as well. If you're liking the content, then please do like the video. It really sends a message to YouTube. You want more of this content. Right, let's get started. So, question 14 here. These are the first four terms of a sequence, and we need to write down the next two terms. So, whenever you get a question like this for the next two terms, the first thing you want to be thinking here is look at the difference between the numbers. So, notice to go from 29 to 22, we need to minus 7. To go from 22 to 15, we also need to minus 7. And then to go from 15 to 8, we also need to minus 7. So to find the next two numbers, we just need to keep minusing 7 each time. So let me draw that in red. And then we just need to work out what calculation that is. Well, 8 minus 7 is equal to 1. And 1 minus 7 is equal to minus 6. Again, you've got a calculator if you need to check those as well. So our answer is going to be 1 here and minus 6. Now, the second part of the question, these are the first 5 terms of another sequence. So 4, 7, 12, 19, 28, and we need to find the nth term. And just like we did in the previous question, what we should start with here are the differences. So let's look at the differences here. So we've got 4 to 7, well, that's going to be plus 3. Going from 7 to 12, that's going to be plus 5. Then we've got 12 to 19, that's plus 7. And then 19 to 28, that's equal to plus 9. Now, in this case, we've actually got a difference of a difference. Now, what do I mean by this? Well, let's do the same thing we just did in the previous question with our differences. So how do I go from 3 to 5? Well, that's equal to 2. 5 to 7, that's equal to 2. 7 to 9, that's also equal to 2. And when you get this so-called second difference, and we'll see lots of questions like this today, so a second difference, you know there is something to do with n squared in our nth term. If there was a third difference that we'll see later on, then it'll be n cubed in some way. So because we have a second difference, there's going to be an n squared in some way. Now, the first step that we need to do, and we always do this for a quadratic, this is what this is called, the n squared, we take that 2 that we just worked out, and we divide by 2. So for quadratic, we always divide by 2, and we'll just quickly do that calculation here. So if we do 2 divided by 2, that's equal to 1. And what this tells us is that we need to write down the 1n squared numbers. Okay, so I'm going to write this sequence out that we've got at the top here, 4, 7, 12, 19, 28, and what I'm going to do now is write down the 1n squared numbers, also known as just the square numbers. So what is 1 times 1? That's 1. 2 times 2, that's equal to 4. 3 times 3 is equal to 9. 4 times 4 is equal to 16. And 5 times 5 is equal to 25. And once I've done that, I'm going to take the sequence from the bottom here away from the top sequence. So what do I actually mean by this? So let's work this out. So 4 minus 1 is equal to 3. 7 minus 4 is equal to 3. You can see the pattern here. 12 minus 9 is equal to 3. And you see we get 3 each time. Now, why have we done this process? Well, we can bring everything together. Notice this is just plus 3. In order to create our nth term, we just take the n squared from before and what we've worked out here, which is the plus 3. And putting that together gives us our nth term. So our answer is going to be n squared plus 3. Now, if this is slightly confusing at this point, we're going to do lots and lots of questions on this. So there'll be plenty of chance of practice. Those are the answers there. Again, this OE, by the way, means or equivalent. So say I wrote 3 plus n squared, and that is also correct as well. You can also see where you pick up the method marks. On to question 6. So the nth term we're given this time is n squared plus 3n, and we want to generate a sequence. We want to find the first 3 terms. So the way we do this is we just substitute in 1, 2, and 3 into our nth term. So let me show you what this means. So the first thing we're going to do, wherever we see an n, we're going to replace it with a 1. So we get 1 squared plus 3 lots of 1. Let's just calculate this. So 1 squared, 1 times 1 is equal to 1. 3 times 1 is equal to 3. And so the first number of the sequence is going to be equal to 4. Now we do exactly the same process, but instead of having an n here, we're going to put a 2. So we get 2 squared plus 3 lots of 2. So if I use the highlighter just to show what's going on here. So the 1 here and the 2 here. This is just replacing the n each time in our nth term. So if we do this, 2 squared is equal to 4. Again, you've got a calculator to work this out. 3 times 2 is equal to 6. Remember, BIDMAS, timesing first, then adding. And then 4 times 6 is equal to 10. And again, we can do the same thing with 3. So we get 3 squared plus 3 lots of 3. 3 squared is equal to 9. 3 times 3 is also equal to 9. And therefore we get our third term of the sequence. So this is what we've been trying to look for, these numbers here. So 4, 10, and 18, which we're going to write over here, like so. And now we've got the first 5 terms of a different sequence, and we're going to find the nth term of this sequence. And again, the first thing that we do here is check the differences. So here, 25 to 18, that's going to be minus 7. 18 to 11, minus 7. 11 minus 4, going down in 7s. And so when we get a first difference that's the same, this is actually easier to work out. So our nth term is equal to minus 7, so that comes from the difference. We put an n next to it, it's an nth term. And then we think to ourselves, let's take that minus 7. What do we do to the minus 7 to get to the first number, 25? So imagine you have minus 7, here's 25. What do we have to add here in order to get to that number? And in this case, we need to add 32. You can check that, of course, on your calculator. So our final answer here is minus 7n plus 32. So when you have a first difference that's the same, this is quite a straightforward process. You saw in the previous question with quadratics that when you have a second difference, it can be a bit more complicated. Okay, you can check the answers. Notice I wrote this the other way around, which is absolutely fine because of the OE, or equivalent. Okay, and on to the next question. So this comes from a paper 4 rather than a paper 2, so it's going to be a little bit more involved. So these are the first 4 terms of a sequence. Write down the next term. Well, let's see what's going on here. Well, this is going down in 4. 11 minus 4 is 7. 7 minus 4 is 3. 3 minus 4 is minus 1. So if we minus 4 again, think of it like temperature. It's minus 1 degrees. It gets 4 degrees colder. Then that's going to be minus 5. And this is an interesting question. I haven't seen many like this. So write down the term-to-term rule for the sequence. So all they're asking for is what's happening each time. So all I need to do is write down that we are subtracting 4. That is what's known as the term-to-term rule, just subtracting 4. Now the nth term we do just like the previous question. So first of all, we take that minus 4, we put an n next to it, and then we look at that difference. So we look at the minus 4, we look at the 11, and then we say to ourselves, what do you do to minus 4 to get to plus 11? Well, that's going to be plus 15. So this is where that 15 comes from. I'm thinking in my mind here, what do I do to minus 4 to get to 11? Well, that's going to be 15. So that's our answer, minus 4n plus 15. On to part B of this question. So the nth term of a different sequence is 2n over n plus 1, and we need to find the difference between the 5th term and the 6th term. So let's work out the 5th term and the 6th term first of all. So the 5th term, the way we work this out is wherever we see an n in this calculation, we put a 5. So we will get 2 lots of 5 over 5 plus 1. And if we do that calculation, 2 times 5 is 10, and then we get 5 plus 1 is equal to 6. Now we do exactly the same process with the 6th term. So wherever I see an n, I'm going to put a 6. So we get 2 lots of 6 over 6 plus 1. If I use the highlighter here, so this is what I'm replacing here, the n with a 6. And if we work out that calculation, we get 12 over 7, like so. Now at this point, it wants us to work out the difference between them, so the difference between the 5th term and the 6th term, and we want to give the answer as a fraction. So what it's asking for, and you can do this either way round, we've got 12 over 7, and we want to find the difference between that and 10 over 6. So you can write it both ways round, 12 over 7 minus 10 over 6, or the other way round. Now the reason we're going to do this is now we're going to find a common denominator. The easiest way to do this is do 7 times 6, which is 42. So we're actually going to do some fraction work here, which is always useful. And now we work out what we need to do in the numerator. So we times 7 by 6 to get 42. So we need to do the same to the top. So 12 times 6, that's going to be equal to 72. Again, check this on the calculator. What do we do to 6 to get to 42? Well, we times by 7. So 10 times 7 is equal to 70. And now we can just minus the fractions by minusing numerators, the top numbers. That gives us then 2 over 42. Now I'm sure that would be fine for the answer, but again we can simplify this by dividing by 2 top and bottom to get 1 over 21. So our final answer here, and we always want to simplify if we can, is equal to 1 over 21. Now on to the last question here, is 3/4 a term in the sequence? Now the way we generally do this is as follows. So we take the nth term, so 2n over n plus 1. We make it equal to the number we're looking for, so 3 over 4. And then we want to find, is n an integer or a whole number? If it's a whole number, it's in the sequence. If it's not a whole number, it's not in the sequence. So that's our strategy here. Now the easiest way of solving this is using cross multiplying. So we're going to do this times this and this times this. This is a technique you've seen in many of my videos before. So 4 times 2n is equal to 8n. 3 times n plus 1 is 3 lots of n plus 1. And at this point, this is just an equation to solve. So we're going to expand the bracket on the right-hand side using the hook. So 3 times n is equal to 3n. 3 times 1 is equal to 3. Then we want to get all the n's on one side. So what's the opposite of plus 3n? Well, we're going to minus 3n on both sides. 8n minus 3n, that's equal to 5n. This cancels, this is what we wanted. So this is equal to 3. And you can probably see n is not going to be a whole number here. To work out what n is, the opposite of timesing by 5 is dividing by 5 on both sides. This cancels, we're left with n is equal to 3/5. And this is not a whole number, so it's a decimal, not whole number. So 3/4, I'm going to be really clear to the examiner here, not in sequence. So the examiner can see very clearly that I've made this conclusion. 3/4 is not in the sequence. Okay, so you can check through that answer there. This has come from a paper 4, so as you can see, it's a little bit more detailed. And on to question 5a. So the nth term of a sequence is 60 minus 8n, and we want to find the largest number in this sequence. Now the first thing to notice, because we have a minus 8n here, it is a decreasing sequence. So if we find the first term of the sequence, that is going to be the highest number that it can be. And the first number in the sequence is going to be when n is equal to 1. So I'm going to copy out this nth term, and wherever I see an n, I'm going to put a 1. So we get 60 minus 8 lots of 1, which is just going to be 60 minus 8, which is 52. Notice every number after 52 is going to get smaller, and therefore this will always remain the largest number. Now here are the first 5 terms of a different sequence, and we need to find an expression for the nth term. Again, always the first thing to do here is look for difference. So here we've got a plus 7, here is also a plus 7, this is also a plus 7, and this is also a plus 7 as well. So to find an expression for the nth term, again we do it in a similar way to what we did before. We have 7n because we have an nth term, and now what do we do to the number 7? So this 7 here to get to the first number 12. So to visualize this, we've got 7, we want to get to 12. What do we add on? And that's going to be add on 5. So our final answer is going to be equal to 7n plus 5, like so. Again, you can check the solution there. You can see they've written in exactly the same way. And on to the next question. This is a little bit trickier. So here we want to find the nth term of each sequence. This is towards the end of the paper. Again, we always look at that difference. So here we've got a plus 7. And see the differences get a little bit tricky here. So if you need to use a calculator at any point, that is absolutely fine. So here we're going to have a plus 19. At this point, we want to find the difference between 34 and 70. That's going to be 37. And then 132 minus 71. Again, you can always just work this out old-fashioned way using the standard methods, and then we get plus 61. Now we look for the next difference. So here we've got a plus 12. Then we have a plus 18. And then we've got a plus 24. So we don't even have the same second difference, but when we get to the third difference, notice we get plus 6 each time. So in this case, this doesn't come up that often. This is a third difference, so the sequence has something to do with n cubed. Now, the first thing we need to do when we get a cubic sequence, I'm going to do it over here, is we take the 6 of our difference, and because it's a cubic sequence, we divide by 6. This is worth remembering. That's equal to just 1. So what I'm going to do here at the bottom is I'm going to write down my sequence, and I'm going to write down the cube numbers, the 1n cubed numbers. So that's 1 times 1 times 1, which is 1, 2 times 2 times 2, that's equal to 8, 3 times 3 times 3, that's 27, 4 times 4 times 4, 64. Again, you can use your calculator for this as well. And I'm going to subtract, like I did earlier, one sequence away from the other. So 8 minus 1 is 7, 15 minus 8 is 7, 34 minus 27 is 7. Notice we get 7 each time. That's very, very helpful. So we get a plus 7 here. And so our nth term is going to be built up by the n cubed here and the plus 7 together. So even cubic sequences you can do in exactly the same way as how I did the quadratics as well. Here we have a slightly different question. So first of all, we have the numerator and denominator. So we're going to treat this separately. The first one we have 2, 3, 4, 5, 6. So we're adding on 1 each time. So the numerator is going to be easier to work out. So our nth term for the numerator is going to be 1n, or just n. And then what do we do to 1 to get to 2? Well, we add on 1. So the nth term of the numerator is straightforward here. It's just n plus 1. What's a bit trickier is the bottom part here, because this is the first time we've seen what's called a geometric sequence. Notice we're timesing by 4 each time. Now there is a formula for the geometric sequence, so when you get timesing or dividing, and the way that we work this out is this formula here. So AR n to the power of n minus 1, where a here is the first term, and the r here is what's called the common ratio, so what we multiply by each time. So if we use it for this particular question here, the first term of our sequence is 1, so it's going to be 1 times, r is equal to 4, and then we get to the power of n minus 1. And the way we always approach fractional nth terms is we do the numerator separately as an nth term, and then the denominator separately as an nth term as well. So you can see the answers there, exactly the same as what I got there, and where you're picking up those method marks. All right, on to our last question for today. So this table shows the first 5 terms of a sequence, and we need to work out the nth term of each. So if we start with sequence A, let's see what's happening here. Well, we've got 8 minus 5 is equal to 3, minus 5, minus 5. So it's going to be a nice, easy one to work out for sequence A. So our nth term is going to be minus 5n. And then what do we do to minus 5 to get to 8? Well, we're going to add on 13. Once you get the hang of this, it's a straightforward process, particularly these linear nth terms. Now, sequence B, what I'm going to do before I even solve this is I'm going to change the first number to 2 over 1, so we can see a clear sequence on the top and the bottom. Now, the top is exactly the same as what I just did in this question, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. So that's the same as n plus 1. And now let's do the bottom sequence. So we're going up in ones, like so. So plus 1. And so the nth term for the denominator is going to be 1n, because we're going up in ones. And then what do I do to 1 to get to 1? Well, nothing. So I just leave that as n. So these are both linear sequences, both the numerator and denominator. Just do them separately, one at a time. Now, sequence C is a little bit trickier because here this is a multiplying sequence, just like we did before. So we're timesing by 2 each time. And remember the formula for that, if I just write it out again, is ARN to the power of n minus 1. So the first term is equal to a half. So we just write down a half. What we're multiplying by is equal to 2, and then to the power of n minus 1. Now you'll notice the mark scheme writes it slightly differently. That is perfectly fine as an answer, but notice a half can be written as 2 to the power of minus 1. So you could actually combine this by using indices laws to actually get 2 to the power of n minus 2. n minus 1 is equal to n minus 2. So you'll see here on the next slide that they write it that way, but of course writing it the way I've written it here comes directly from the formula and is absolutely fine for all 5 marks. If you want to check out some work on exactly how to use the sketching of graphs to actually work out various solutions and working with tangent lines, then do check out the video in front of you, because that goes through all the details that you need to know to do really well on those questions.